On October 22, 2025, Yellowstone National Park experienced dramatic geological upheaval. Beneath tranquil pine forests, reflective lakes, and dancing steam clouds, a gigantic force was at work. In less than 24 hours, 4 geothermal and tectonic events occurred nearly simultaneously. A rare, if not extraordinary, event in the history of scientific observation in the region. A massive steamboat geyser eruption, a new fissure after a magnitude 6.7 earthquake, the discovery of a new thermal area in a previously dormant zone, and fumarole eruptions from Black Diamond Pool all occurred with overlapping timing and intensity. Scientists monitoring the park for years recognized, for the first time, a pattern of activity that was not merely anomalous, but potentially a sign of systemic change in Yellowstone's dynamics as an active supervolcano. These 4 events are not isolated. Their spatial and temporal connections highlight the complex interconnectedness of Yellowstone's hydrothermal and tectonic systems. It began with a magnitude 6.7 earthquake that occurred at approximately 3:47 a.m. local time. The epicenter was located beneath Yellowstone's northern geothermal zone at a depth of only 8 kilometers, shallow enough to affect the overlying hydrothermal system. The earthquake was felt as far away as Montana and Idaho, and recorded horizontal ground motion of 4 to 6 centimeters in some locations. GPS sensors and ground deformation monitors confirmed crustal dislocation in several key areas of the park. A few hours later, Steamboat Geyser erupted on a scale not seen since 2019. This eruption not only included a vertical plume reaching 100 meters high, but also involved a massive release of heat and steam that lasted nearly 70 minutes. Thermal cameras showed a temperature spike of more than 30 degrees Celsius within a 500-meter radius of the geyser, and sulfur gas levels doubled compared to normal. Scientists suspect that seismic waves from the earthquake disrupted the internal pressure in a pocket of superheated underground water, triggering a major eruption. While attention was still focused on Steamboat, a USGS field team reported the emergence of new fissures in the Midway and Norris Basin zones. Some of the fissures even appeared along common hiking trails measuring 15 to 30 centimeters wide, with thin plumes of hot steam beginning to rise from the cracks. This indicates the migration of heat from the Earth's interior to the surface through new pathways created by post-earthquake fracturing. This phenomenon is extremely rare on such a narrow scale and at such a rapid rate. Most surprising, however, was the report of a thermal reconnaissance drone unexpectedly discovering a new thermal area on the northeast side of the park, near a valley previously thought to be stable and geothermally dead. The soil in this area exhibited surface temperatures of 89 to 94 degrees Celsius, and acid mud pools and significant sulfur gas venting were observed. These findings indicate that Yellowstone's hydrothermal system is branching, a term scientists use to describe the widening or formation of new underground heat circulation pathways. This phenomenon is extremely rare and has never been directly recorded in Yellowstone's modern monitoring era. Climaxing this sequence, Black Diamond Pool, a hydrothermal pool known for its calm and stability, experienced 2 fumarole eruptions within 12 hours. The second eruption was high pressure, sending steam, hot water, and mineral particles more than 10 meters high. Chemical sensors installed around the pool recorded significant increases in carbon dioxide and hydrogen sulfide, 2 gases often associated with shallow magma releases or extreme hydrothermal pressure. The combination of these 4 events suggests that the Yellowstone geologic system is not moving randomly, but may be undergoing an active redistribution of pressure and heat pathways, resulting from a disruption of its internal equilibrium. Yellowstone, as a supervolcano with a giant caldera and a vast magma chamber beneath it, has a history of activity ranging from stable to catastrophic. However, a scenario like this, where a major earthquake, a geyser eruption, the formation of a fissure, and the emergence of a new thermal zone occur almost simultaneously, is extremely rare and has never been fully documented in a single day. For scientists, the events of October 22 are not only a matter of technical analysis, but also reinforce the urgency of the need for new models to predict the evolution of the Yellowstone geothermal system. This system is not static. It evolves, changes, and responds to pressures coming from within the Earth and the surface. And when 4 major events occur within a narrow time frame, it's clear that something is happening at depth that we don't yet fully understand.